Now we have prepared and checked the geometry, we're ready to set up an analysis on the assembly. The FloEFD project is created using a wizard-driven process. Flow and thermal boundary conditions are applied directly onto the NX parts. If materials have been applied in NX, these can be imported directly into the FloEFD engineering database. Let's start the wizard and look at the steps. The first step is to name the project. We can also see that the project can be created on the NX family of assembly members if needed. This project is an internal analysis, as the inlets and outlets are well defined. The exclude cavities without flow conditions is enabled to ignore the previously seen cavities. Heat conduction in solids is enabled to consider conduction and convection. Water is chosen as the working fluid. The wall conditions are left at adiabatic to ensure all heat is transferred to the water. The ambient temperature is set to 65°C to replicate under hood conditions. Once the wizard is finished, we can see the computational domain around the assembly, which has been sized automatically based on the wizard selections. Let's quickly import all the NX materials which have been assigned. The assembly is scanned and we can accept the detections. Materials can also be applied manually. Here we're applying silicon on the chips themselves from the independent FloEFD materials library. This is useful as not all NX material definitions have temperature-dependent properties. Next, we'd like to assign the water flow conditions using a boundary condition from the ribbon. A volume flow rate of 1.5 gallons per minute is applied to the inner face of the lid we created earlier. The thermodynamic properties show the inlet water temperature of 65°C. In a similar manner, an outlet pressure condition is applied to the other lid. This will allow the water to leave the system and gives a known pressure condition. A volume source is used to apply a heat load. Multiple parts can be selected at once and the power will be split across the bodies. We'll apply 360 watts on the IGBTs and 144 watts on the protection diodes. Like this, other FloEFD features can be applied directly onto the NX geometry. The FloEFD project is initialized with the wizard and can be applied at any stage of the design process. The engineering database can be shared across a team to ensure consistency. FloEFD data can be reused and persistently associated with a part if desired. Projects can be cloned and templates created to standardize the analysis setup stage. To recap what we just saw, the analysis setup is performed in NX using a wizard-driven process. Analysis boundary conditions are applied onto the assembly parts and features. The benefit of this step is that it's quick and intuitive to set up an analysis for the design engineer.